Star Wars music.
Yeah.
And I'm talking about another Earth today.
You're going to need to use the mic, please.
Yeah. So I'll be talking about another Earth today. Before I start though, I would like to thank Austin Astronomical Society and the Thinkery for letting me present today. So my name is Anshuman and I'm very interested in astronomy. I want to be an astrophysicist and I'm a freshman at McNeil High who plans to take astronomy courses in aerospace science. I have already completed a few college-level astronomy courses from Caltech by Mike Brown and then one from the University of Edinburgh on Coursera. So we'll be talking about another Earth, but to do that, we need to understand why Earth itself is so special. Earth is special because of you and me. Earth is the only planet with no life, and it has the perfect atmosphere and composition and the perfect placement for this planet to support life. But the question remains, are we alone? Before I answer that, I will need to talk about something called the Goldilocks zone. I'm sure you all know the fairy tale where Goldilocks has porridge that's too hot or too cold, and she has a bed that's too hard or too soft. In the same way, a planet has to be just right and not too hot or too cold or too large or too small for life to be able to form. This is why the Goldilocks zone is also called the habitable zone. And as you can see in this diagram here, the hotter a star is, the further away a planet has to be in the Goldilocks zone. And you can find life in the solar system as well. There are many places that there might be life outside of Earth, but still inside of the solar system. I will be talking about these three today, because they are the most viable, and we will see why once they start explaining. First up is Europa. Europa has a worldwide ocean under a thin shell of ice, which is about 50 kilometers thick. It also has a rocky core that interacts with the water, as you can see in the diagram over there. Europa has liquid water, even though it is outside the habitable zone, because Jupiter's gravitational tides heat the water. So the habitable zone for planets may vary on the star's heat, but it really depends on the planets where life can actually be found. And the fact that Europa has a worldwide ocean is very important because life started in oceans on Earth. It will probably start in oceans on other places as well. Enceladus is here for a similar reason. The Cassini spacecraft discovered meltwater geysers spewing out of its south pole, as you can see there. These geysers are actually water that's being immediately frozen on contact with space. Therefore, life may exist here too. However, the theory is now that just a major impact tens of thousands of years ago formed like a pocket of water. So this may not be entirely true for Enceladus. Titan, however, is on this list for a completely different set of reasons. It is the only moon with an atmosphere which is thick like Earth's. And it also has both oceans of ethane and methane, which are the dark regions here, and land, which are the lighter ones. This makes it very similar to Earth in terms of physical characteristics. And the Cassini-Huygens later discovered these oceans of liquid methane and ethane, which could very well be the starting point of life that is not based on water. But can you just only discover life in the solar system? No. It's a wide, wide universe, and there are billions of possibilities of life out there. But where do we start? We start with exoplanets. Exoplanets are planets in orbit of another star. Most were discovered by the Kepler mission using either spectroscopy or Doppler shifts in star orbits. Doppler shifts are when the star wobbles in its orbit because of the gravity of the planet going around it. And over 5,000 exoplanets have been discovered so far, and they are still being found today. Exoplanets are determined to be habitable by their atmosphere, surface conditions, size, and temperature, to name a few. These are measured by star occultations, which is when the planet passes directly in front of the star, and by spectroscopy. Many planets are theoretically capable of supporting life. In fact, the closest one, Compete B, is only about 12 light years away. Some other notable exoplanets are Kepler 62e, 452b, Gliese 832c, and Kepler 442b. You can see here a chart comparing them with Earth. And as you can see, they're all very similar to Earth, and some are actually better for planets to survive, which is what this is, than Earth itself. I will be talking about two other exoplanets, and this is one of them. This is Fomalhaut b. It's a forming exoplanet, and it's actually the first seen in visible light by the Hubble Space Telescope. This means we didn't have to use Doppler shifts or star occultations to find it. We could actually see it, and we knew it was there. The fact that it's still a forming exoplanet is also very important because we could be very well taking a look back in history when the Earth itself formed by watching this planet. The other planet I'll be talking about is Gliese 581g. This exoplanet is dubious, meaning it may or may not exist. However, if it does, it would be the most Earth-like planet found today, and may even have life on it. It would be interesting to see if this really has intelligent life. Scientists estimate there's at least one planet for every star in the Milky Way, and 1 in 5 of those planets can support life. So there is a possibility that there is life outside the solar system, but we don't know for sure. This time there are more questions than answers, but do you have any questions for me?
How old are you?
Has to be an astronomy question.
Oh,
You can answer that question as well, though.
I'm 14.
you're great.
Thank you.
No questions from us?
So those indexes that you were showing were the habitability potential of the planet was greater than Earth's. How are those calculated?
Well, basically, it measures the atmosphere by star occultations and spectroscopy, and they use those to find out whether a planet is viable for plant life. Earth is actually a little bit low because of global warming and all the animal life and stuff. So that's why some have higher indexes there.
Can you talk more about why Gliese is dubious?
It's basically just readings. Some scientists use readings. They say, yes, it exists. Some scientists go over them, say, no, it was just a glitch. Sorry. No, it was just a glitch. There's nothing there but a gas cloud. So, yeah. Yes?
So how do we decide that 1 in 5 are probably habitable? Is that based on what they've already found? Or-
Yes.
So 1 in 5 stars, the exoplanets that they found have fallen within a habitable zone?
Yeah.
I just wondered how you got interested in exoplanets.
Well, I was interested in astronomy, and this was a topic that seemed interesting, so.
Yeah, I think that's life. That makes a lot of sense.
Terry Eagles marching orders.
So you said that Earth is slightly off from the ideal point in the habitable zone. Are we closer or further from our sun on that side of that kind of median line?
A little closer because Mars would be on the other side, just barely outside the zone. So we were on the closer side. Any other questions? Thank you.
All right.
Thank you.